So now we'll start talking about databases. Okay. Now, if you want to learn databases, like in engineering, databases like a whole concept altogether. Like there is a whole subject databases, right? And sometimes there is an elective advanced databases kind of stuff as well. But with a developer's perspective, if you want to get started fast, then let me tell you what is a database. So at any point of time, if you see any application around you, let's take an example of something like let's say Zomato. Okay. So let's say this is Zomato's application. Now this is the page of a restaurant, right? This is the page where food items of a restaurant is present. And let me show you one more page. This is like a page of the restaurants. Okay. Now every time you open Zomato, let's say you search for biryani, right? There will be a bunch of restaurants that will come up. Let's say we clicked on Behrouz Biryani, then what will happen? This screen will actually come up and you'll be able to see the list of available biryanis that Behrouz actually offers. Now, what point I want to prove here? The point that I want to prove here is that the data about the restaurant, what food items the restaurant is actually serving, all of that data needs to be stored somewhere, right? Every data getting used in our app needs to be stored somewhere, right? We have to store it somewhere. Now, if you go back to your school days, like I'm not mocking any teacher or something, but at least in my time, 2013, 2012, school teachers used to maintain something called as an Excel sheet. And to be very honest, let's go even back. So when I was in 7th, 8th class, my school teachers used to maintain something like a register. This is like a actual hard copy, like register was there. In that register, like they used to write the name of every student. Then there were a lot of columns. Every student's attendance was marked in that register and everything. Okay. And for a very long period of time, when computers were not that relevant, this kind of a data storage mechanism used to happen, that we used to actually manually write on pen paper. But there is a very significant problem with this. What is the problem? If let's say my class teacher needs to give some data to my in charge, floor in charge, then either they have to give the whole register to the in charge, or in charge used to manage their own copy of the register, and they used to copy the data from class teacher's register. In case the data in the class teacher's register changes, then the in charge's register used to change as well. And this is definitely one of the worst ways to store data. But again, depending on the constraints time to time, this was something that we used to do. Then later when I came to like 12th class, and like then when I came to college, then teacher used to maintain Excels. Then teacher used to maintain Excels. At least Excels are a bit fast to maintain. They are more like, what's the problem with the register? If somehow let's say this register burns down to hell, this is gone. It's very hard to prepare backup of this register, right? Like photocopy of a very big class register, it's like challenging, and maintaining photocopies is expensive and everything. So later, teachers and everyone migrated to Excels. So what was a good benefit with Excels? Backup was easy. Backup of Excel was easy. Like you just create a copy and store it, right? But still it exists. There existed a problem that teachers used to maintain their own dedicated class Excels. Then let's say HOD needs some data, so HOD maintains their own Excels. If Excel of the class teacher changes, or a subject teacher changes, the HOD has to manually change it. There was no sync and everything, and there was a lot of data repetition. Data repetition was in registers also, but registers are way bad. Excels also had the problem of data repetition. Like same students marks and their enrolled courses and all of these detail used to be maintained in a lot of Excels. Very havoc. Even when let's say teacher used to check the copies of exams, they used to upload the and they have to send it to the university. So they used to upload all the exams in a Excel sheet and then send it to the university, right? So lot of problems. Then COVID came up and people realized that they need to be a bit more digital in at least school and university environments. And then they started using something called as an LMS, learning management system. This learning management system was great. Why? Because they used to just give the teachers an interface. They used to just add the data, and anywhere any teacher wants to fetch the data of a student, which is accessible to them, they can directly fetch it. They don't need to maintain their own copy to fetch to keep the data, right? And these LMS actually changed everything. These LMS were not using Excels or like manual registers, right? They were actually using dedicated data stores, right? They were using dedicated data stores inside their hosted machines to actually store their data. And the solution that they used to use was so great that the problem of data repetition, getting multiple data from multiple data stores, all of that problem used to get very easily handled. And these data stores we formally call as DBMS, database management system. DBMS, database management system. So what's the power of DBMS? In DBMS provides you to access data in a very easy way. It helps you to store data in a very easy way. It helps you to back up data in a very easy way. It lets the applications use this data in a very easy way. So database management system. So it's an end-to-end solution that is provided. Internally, DBMS can store data in different format. It's kind of like when you see a data structure, like trees. You can insert some data in a tree, you can retrieve some data from a tree. Linked list, you can insert some data in a linked list, you can retrieve some data from a linked list. But internally, linked list stores the data absolutely in an end-to-end different way, and trees store the data in an absolutely end-to-end different way. Arrays store the data in absolutely end-to-end different way. Similarly, database management systems also, different database management systems might store data in absolutely end-to-end different way altogether. So there are different type of databases. Okay. So generally databases are divided into two categories: SQL and NoSQL. What is a SQL database? SQL database, if I just tell you in a like a nutshell, in a summary, they store data in table format. This table format we also call as a relational format, right? Relational format. So every data that you see in SQL is actually stored in the form of tables. Whereas NoSQL do not store data in the form of tables. They might be storing data in the form of key value pair. So there are some NoSQLs that stores data in a key value pair form. For example, Redis. Some NoSQL store the data in a document form. For example, MongoDB. Some NoSQL store them in a format of a graph data structure. For example, Neo4j. Neo4j, right? And so on. So different type of storage structure they use, but they do not use tables. Here we use tables. So for example of SQL supporting databases: MySQL, PGSQL, Oracle DB, and so on, right? Now, they have their own set of advantages. We can talk about their advantages and disadvantages later. But this word SQL is something that I'm very interested in talking about. What is SQL? SQL stands for Structured Query Language. Okay. SQL stands for Structured Query Language. In order to retrieve data from SQL supporting databases, you have to actually write SQL queries. So to retrieve data, we write SQL queries. When I say SQL queries, you can understand that this is like kind of like SQL code that you have to write. So this SQL also has a proper syntax that you have to write, using which you can actually retrieve some data. But here is a fun fact. When you hear the word SQL, structured query language, you get a feeling that, oh, this is also a language. This is also some kind of language like JavaScript, C++, Python, kind of like that. But technically it is not. So SQL is kind of like a standard. So SQL is a set of recommendations, or you can say a documentation that provides a standard that If there is any relational database or a SQL database, and they want to support a language using which people can retrieve data, people can update data, people can store data, they can follow these standards and prepare their own SQL. This is the reason why there are 90% syntactically, 90% syntactically, all of the SQL databases are same. For example, if you have to retrieve data from MySQL, you write a syntax like this. Let's say select star from table name, something like this. Fun fact is, this same syntax you can write in Oracle DB also. This same syntax you can write in PGSQL also. Why? Because all of them follow the same standard of SQL, that if you want to prepare a language or you want to prepare an interface using which people can actually communicate with your database, retrieve data out of the database, or store data out of the database, store data inside the database, you can follow these standards, because this is going to be more or less consistent across SQL databases, and you can follow that. But it's not mandatory to follow end to end this standard. It is not mandatory to follow end to end this standard. There are a few things that MySQL do not follow from this standard, or PGSQL do not follow from this standard, right? Very slight differences. That's why I said 90%. If you know any SQL database, 90% other SQL databases, 90% syntax is same, so you will be able to very easily work there. There will be just 10% differences, like SQL supports some features, PGSQL doesn't support that feature, or PGSQL supports some feature, Oracle doesn't support that feature. Some slight 10% minor changes are there. Are able to get this point? So it's kind of like in let's say in a country like India, central government, let's say, releases a notice that this is kind of like a recommendation for most of the states to follow. So generally what the states do, for example, let's say they are releasing a notice for pollution, that this is kind of like the set of recommendation that we are giving to control pollution to all of the states of the country. Now the states of the states of our country, 90% do follow those norms, but 10% they can make some changes as well. For example, let's say in Delhi, people like the government of Delhi uh, promotes even odd driving kind of stuff. Maybe in and let's say, and let me tell you one more thing. For example, let's say for crackers, right? Delhi government banned crackers absolutely end to end. But what Karnataka government did, they said that in the Diwali week from evening 8 p.m. to 10 or 10:30 p.m. you can burst crackers. Rest in the whole day you cannot. So most of the things they are following for pollution, that this should be followed. Carbon emissions should be less. Vehicles of petrol should follow 10 year for 15 years life. Most of the things they are following. Sometimes few changes they do here and there. Similar thing exists here as well. This is a set of recommendation. This is a standard that any SQL is going to follow mostly this standard, but a few changes here and there they are allowed to do, or they generally do, right? So any SQL you will learn at least syntactically to get data, add data, update data, all of that stuff you will be able to do to other SQLs as well. Very easily. There will be just 10% few changes here and there that you can learn on the go, right? And fun fact, SQL databases are so popular that still more than 65 to 70% of the applications that you will see on the internet are heavily powered by SQL databases only, right? In Google, we have something called as a Google Spanner. In Google, we have something called as a Google Spanner. Google Spanner is a NoSQL database, but it gives us support to write SQL queries to fetch data from a NoSQL database. So nowadays, this thing is also getting pretty much relevant, that internally things are stored in a NoSQL format, but to retrieve the data, to get the data, to store data, to update data, to delete data, all of this stuff you can do with a SQL query, kind of like a syntax. We'll talk about SQL query and everything. So this is kind of like databases. Every database has got their own set of advantages, disadvantages. For example, let's say if you want to have, you want to store some cache, you want to store some kind of a cache layer, using Redis makes sense. If let's say you want to store transactional data, let's say data related to payments and everything, using a SQL makes more sense. If you have very unstructured data, then these NoSQL, specifically a document based DB like MongoDB, makes more sense. If you want to store data like a social network, that is where graph like data is stored, Neo4j is something that you can use. So every database has got its own set of advantages and disadvantages. In fact, even in SQL, you will see that different databases, different type of SQL support one, two extra features as well. For example, there is something called as a SQLite. What is SQLite? SQLite is a very light and a small scale SQL database. It is generally used for testing purpose and everything. But generally, MySQL, PGSQL, and Oracle DB are very highly scalable databases as well. PGSQL adds some more supports, like PGSQL supports some more type of data types as well. Oracle, I'm not sure, but I guess it's a paid, so they maybe give some customer support also. I'm not sure. Although in LinkedIn, Oracle DB was used, but I don't know the difference between what extra Oracle DB offers. Right? I never read about it. Okay, so that's what you need to know about databases, that now we have these database management systems, and we can interact with these database management system to store data, retrieve data, delete data, update data, do a lot of operations, very complex level operations, very easily. Also, these SQL databases, as I said, they store the data in table like format, or you can say relational format. So due to this word relational format, these are also called as RDBMS, relational database management system, because they store data in relational format. And where this word relational comes from, so in mathematics there is something called as relational algebra. So technically these tables and everything do support relational algebra, but from a developer perspective, from day to day actual coding perspective, you don't have to do relational algebra actually. Like till now, throughout my journey in coding, whenever I've used SQL, I've never done any kind of relational algebra actually. Yeah, you need to know how to create tables, how to store data, how to do joins and everything, complex operations. But algebra I have never done to store data. But there is, like, theoretically you can do algebras and everything. That's where the word relational comes from. So that's why we call it as relational database management system. But you can simply understand that they store data in the form of tables. They actually store data, let's say, in the form of a document or key value pair or something. For example, let me actually show you. So there is a very interesting article from MongoDB, right? How MongoDB stores data. So they actually have a very interesting article as far as I know. How MongoDB store the document. Okay, this is a community article. One second. There is an official article as well. Uh, MongoDB stores JSON, BSON. Okay. See, so if you go here, internally MongoDB stores some, like, if you will see a MongoDB document, no, it looks more or less like a JSON, but internally it stores data in kind of like a BSON format. So internally, whenever you actually see a MongoDB document, it stores data in a form of a BSON. I'll tell you what is a BSON. And even over the network, whenever you are trying to set up a TCP connection and fetch some data, it's a BSON only. But that doesn't mean that you can't think MongoDB as a JSON database. Anything that you can represent as a JSON can be natively stored in MongoDB and retrieved as easily as a JSON. Now, what is a BSON? BSON is binary JSON. That exactly this is, and that's exactly what it was invented to be. Binary structure encodes type and length information, which allows to be traversed much more quickly. BSON adds some non-JSON native data types like dates and binary data, which MongoDB would have, without which MongoDB would have been missing some valuable support. So, like, if you see a normal JSON, JSON is not a language, right? It's just like a way to store a document. So in normal JSON, you cannot store binary data, or you don't have a support for dates. But because of binary JSON, internally it stored data in the form of a binary. So MongoDB adds its own layer of dates and binary data, some extra data types that by default JSON doesn't support. Generally, JSON, I guess, basically supports strings, number, very basic data type, Boolean and everything. But dates and everything it doesn't support. But dates and everything are very important part of MongoDB database, right? So you can actually read about internals, that how exactly data is stored in a particular database, but how they actually store data actually shapes up the fact that what support they give and for which kind of application they are very good, right? So as I mentioned, like, if whenever you will see any kind of banking application, or in your application whenever there will be a payment related data, you will find SQL very heavily getting used. Whereas if let's say you have some unstructured data, for example, if you see Amazon products, different Amazon products have different properties. For example, a phone on Amazon will be having a color property, but it doesn't make sense to have a color property on a book. So this is unstructured data, right? Some data has color, some data doesn't have color. So it's unstructured data. So storing unstructured data also NoSQL is very good, right? So different use cases actually exist. To be very honest, I have never seen an application that is absolutely end-to-end dependent on SQL or end-to-end dependent on NoSQL. Generally, there is a club of both. Some part of your app works on NoSQL, some part of your app works on SQL, right? One thing that you have to keep in mind. Second thing, that SQL, like one more thing that drives the decision, that what your developers know. If your developers know more SQL and you are just making prototypes and in your initial phase of your, I would say, um, project, then using SQL definitely makes sense, right? Otherwise, you can take a decision based on the design call that what support your, I would say, application wants to give.